Before understanding recrystallization process, we need to understand about the grain structure of the metal. A grain is a small region of a metal having a given and continuous crystal lattice orientation. Each grains represent a small single crystal. Now the grain structure of metal is an arrangement of differently oriented grains surrounded by grain boundary. And a grain boundary is the interface between two grains. Basically, they are two-dimensional defects in the crystal structure, and they tend to decrease the thermal and electrical conductivity of the material. These grain boundaries are usually the result of uneven growth when solid is crystallizing. Now, you know the basics of grain structure. Let's understand the recrystallization by taking the example of cold rolling. Now, cold rolling or cold forming is any metal working process in which metal is shaped below its recrystallization temperature, which is usually at ambient temperature or room temperature. As you see here, prior to cold working, the grain size is bigger in the material, whereas after the material undergoes cold working, grain size changes. The grains gets elongated and material compresses. This is only possible when the applied load generates a stress which is higher than the yield strength of the material, and it undergoes plastic deformation. Now, when a material undergoes plastic deformation, the atoms and dislocations inside the material move, leading to the change of the shape. Due to this, several dislocations gets collected at one point and they resist further deformation. Therefore, to cause same amount of deformation, higher load need to be applied, and hence we can say that the strength of material has been increased, and this overall phenomena is what we call strain hardening. And hence, for further working, we need to heat the metal to recrystallize it, to recrystallize and to reorganize its crystal structure in order for facilitating further mechanical working. So we can say that recrystallization is an annealing process in which old deformed grains get displaced by newly formed undeformed grains, and the temperature at which the process is completed at a duration of 1 hour is called a recrystallization temperature. According to ASM, recrystallization temperature is the approximate minimum temperature at which the complete recrystallization of a cold worked metal occurs within a specified period of approximately 1 hour. And this recrystallization temperature is given by T suffix R, and it is equals to 0.4 to 0.6 times of the melting point. Now, the recrystallization temperature of a material depends upon several factors like small grains, type of metal, extent of prior cold work, time, second phase particles, and rate of deformation. Now, if the material is already having small sized grains, then after cold working, we will have even smaller grains, and hence more recrystallization temperature or higher recrystallization temperature will be required to recrystallize it. Now, the interatomic packing of metal, the type of metal used as raw material, also affects the recrystallization temperature. If the material is already undergone cold working, then further cold working would lead to higher strain hardening, and hence more recrystallization temperature would be required to recrystallize it for even further working. Also, the recrystallization temperature is a function of time. If temperature is not raised properly and strategically, it might require more temperature or more recrystallization temperature. So we can say it's a function of time. Now, the presence of second phase particles is another story. The second phase particles, or popularly known as precipitates, impede the movement of dislocation throughout the lattice, and they add second phase strengthening to strain hardening, and these lead to requirement of even more or higher recrystallization temperature. And last but not the least, the rate of deformation. The rate of deformation or the rate of plastic deformation also impacts strain hardening, and hence the recrystallization temperature.